Hello, this is going to be my Chapter 6, Week 6 exam video on geographic range. I have my 12 questions written out. Let's get started. So the first question is, what is the geographical species range? Basically, the geographical species range is the spatial area where a population of species occurs. Question 2, what is extent of occurrence? Extent of occurrence is the specific locations of documented sightings of these species in their geographical range. So if you think about the range being a big circle, big shape, the little dots, little markings would be the exact documented sightings. So that's basically the extent of occurrence. Question 3, what is the area of occupancy? So the area of occupancy is basically when you take the outermost points of the documented sightings and wherever, so there's that would also form kind of the range, the outline from the outermost sightings. So then wherever in the middle, that's the area of occupancy, which is basically just where the species would be found. Question 4, how are ranges outlined? Ranges are outlined basically just what I was explaining by taking the outermost specific documented sightings of that species and then by creating typically a polygon around those outermost sightings, then that's how you would have your species range, and then species would be anywhere inside that borders. So that would be how a species range would be created. Question 5, what is the idea behind niche affecting a species range? So basically the niche theory is that a species is constricted to their geographical range because of environmental impacts and ecological boundaries. Yes, that was the idea, is that basically a certain species, or all species for that matter, they have their perfect sweet spot of temperature and climate that they live best in, and the idea of the niche theory is that this is why they are confined to this one geographical range, is because that's where their environment is best, or because there's ecological boundaries and they can't go elsewhere. So that's the niche idea. Question 6 is the idea of niche supported by the data. Provide an example. So actually there is very little data that supports this idea. An example of this would be the Thalassoma grasse fish, and basically the Thalassoma grasse fish have their sweet spot of temperature where they're able to live best. They have their most suitable desired area, and basically scientists found that they have these suitable best temperatures, best climate areas for them to live all across the world. There's several different locations across the world in the oceans, but they are only found in the one section of the Pacific Ocean, which kind of explains that, yes, they are in that area of the Pacific Ocean because there's that single sweet spot where their living conditions are best, but there's good living conditions everywhere. It doesn't mean that they're found everywhere, if that makes sense. Question 7, can ecological factors affect the range of a species? Explain why. So ecological factors don't necessarily affect their geographical range necessarily, but they can affect the dispersal within that range. Basically, how I would explain this further is that a species or several species can they face competition when existing amongst each other. So either these species are competing for these one area with the best food and water, or they kind of learn and adapt to coexist with each other, and that can explain the dispersal. So an example of this is Robert MacArthur studied 5 different species of warbler birds in North America, and he found that these 5 different species, they were living in the same geographical range, same trees, but instead of fighting over one certain trees or one area of the trees, they would disperse across the trees. So some species would live higher in the tree on certain branches, and then other species would live in the middle of the trees. And this way they were able to coexist. So this kind of explains that although ecological factors don't necessarily play a huge role in the actual shaping, they do play a big role in the dispersal. Question 8, how can evolution affect the range of species? Basically, evolution can affect the range of species by determining why they are where they are. An example of this is the Balissalme grasset fish. And basically, when scientists were studying their phylogeny, they found that that specific type of grasset fish originated 3 million years ago. Also 3 million years ago was when Panama was formed and there was a separation between the Pacific and Atlantic Ocean. Now, if the Balissalme grasset fish was originated, let's say, 7 million years ago, when there was not that separation and there was a gap between the Pacific and Atlantic Ocean, they could be living in both Pacific and Atlantic. But because they originated 3 million years ago when there was that separation, this can explain why they're only found on the Pacific side and why they are unable to disperse to the Atlantic Caribbean side. Question 9, what is the reasoning for the larval period affecting species range in the ocean? Does the data support? Basically, the idea was that the larvae period of a fish, the longer the larvae period was, the longer they would have to disperse, which would mean the further their geographical range could be. This was the idea. So if a fish species had a very short larvae dispersal period, then their geographical range would be smaller. Whereas a species had a longer larvae dispersal range, then their geographical range would be larger because the dispersal would have more time to travel further. So this was kind of the hypothesis. Treasure and brothers went out and tested this idea on a certain fish species in the Pacific Ocean, and they went all across the Pacific Ocean, collected a bunch of data, and when they got the data, compiled it, they found that there was no correlation between the larvae period and like a geographical range of the species. But you would think this makes so much sense. Like, they were really puzzled as to why that this was. So then several other scientists after them went and tested this hypothesis, and they also found no correlation with data. Question 10, do most species have small or large range, and why? So most species have small range. Very few species have large range. This is for a few different reasons. One being speciation. So basically, when a species is originated, they aren't originated everywhere. They're originated in a smaller area. And this kind of explains why their geographical range is small. Second would be the extinction effect. And this is back to the idea of species having a specific environment and temperature and climate that they live best in, that is most suitable for them. So say they originated in their one area that has the most suitable climate, and they did disperse somewhere else, and the temperature was much colder and they were unable to live, they would die off and they wouldn't survive in that other region, which would result in their range not being so large and being more small. Third reason is the dispersal effect, and that is that species just not a lot of species are able to disperse everywhere, and they are typically confined to their smaller geographical ranges. But that's the exception. That's most species. Some species do have larger geographical ranges and are able to disperse more broadly. Question 11. What is the range size frequency distribution? So the range size frequency distribution is basically the idea of, it describes why a species has either a small, medium, or large range of their geographical region. Question 12, explain the range, size, frequency, distribution of fishes in the Eastern Pacific Ocean. So basically, most species have small ranges, but there was a peak in fish in the Eastern Pacific Ocean, and this peak showed that they have higher ranges. And basically, this peak was including both the islands and continents, and also was combined with the geomorphology. So that is all 12 questions. I hope I explained that okay, and I'll see you in the next video.